So, welcome, ladies and gentlemen. We're looking at our homework from last night, page 31, and I'm looking at question 24 here, where our goal is to write an algebraic expression that translates this or represents this. You can see I already happen to have the answer here, but I just want to kind of piece this apart. So let's see, it says the square, so that means I'm squaring something. Now, the odd thing about squaring is that there's not a symbol to represent it, unless you really wanted to do something like that, you could. But what am I squaring? I'm squaring the sum. So what does sum mean? It means addition within parentheses. So I'm squaring the sum, all right, of a number, and I'll use x and 13. And that's how you would do that. So I think it's valuable sometimes to see exactly as I read something what is written and interpreted from every single little word there. So one of the sticky points is just that sum means addition within parentheses. Let's see, we had another request for question 37. Do any questions show up chronologically before 37 you guys would like me to go over, or how about 35? Yeah, 35, guys. Come on, for real. Seriously. Seriously, guys. Seriously? Seriously. So here's 35. I'm guessing I know what the problem is here. You hate fractions. Now, I'm going to show you how to do this a couple different ways. So first of all, this is a little bit tricky, is that the 1/8 is positive here. And oftentimes people see this minus sign and think, oh, I need to add 1/8 to both sides. But no, the negative is applying to the negative 3/4. That's multiplied by the x. So the 1/8 is actually positive, and if I was to move it, how would I move it?
You have to do 4.
We're going to have to do LCD stuff in a moment, but how would I move this positive 1/8 to the other side? Ideas? Ignoring fractions. Pretend it was a happy number. Pretend it was the number 1. How would you move, if this was just 1, how would you move it? You'd subtract it, right? So subtract an 1/8 from both sides. Subtract an 1/8 from both sides, right? Beautiful stuff here. And I would have negative 3/4 x, and I'm lining up my equal signs kind of vertically here, equals, and I realize, uh-oh, I don't know how to combine a 16th and an 1/8. I need a common denominator. What is the LCD between those two things? 16. So I'd have to multiply this one by 2/2 to get that. So this is the same as negative 2/16. Do we agree? Let me write some more steps in here. So I've got 1/16 minus 2/16. And what does that combine to? 1 minus 2? Negative 1/16, exactly. Yep. And how do I get rid of this negative 3/4? Do I add it to both sides? No. What is the negative 3/4 actually doing to x? Because it's not x minus 3/4. What is it? It's negative 3/4 times x. We will. Multiply by what? No. Well, to get rid of multiplication, you technically divide both sides by this thing, but that doesn't sound like fun, a fraction divided by a fraction. So the other way we can deal with it is multiplying both sides by the reciprocal. So negative 4/3 multiplied by negative 4/3. Okay? And behold what happens. I'm going to go fruit ninja on this. These minus signs cancel out. The 3's cancel out. The 4's cancel out. And I get x by itself. That's exactly what I wanted, right? X. And over on this side, the minus signs cancel out, so it's positive. And then 4 and 16, what number goes into both of those? 4. 4 goes into 4 once and into 16 4 times. So I'm left with 1 times 1 up top, which is 1, and 4 times 3 on the bottom, which is 12. So I get 1/12. So That is brute forcing your way through the fractions. Let me show you same problem, alternate approach. And because I heard that someone hates fractions, I'm going to show you an ethically wrong way to do this, but it's very effective. What if I could present you with a world where fractions didn't exist? Is that, you'd like that world, I imagine? What if that world could be obtained by, I don't know, killing all of the fractions on the planet? Is that something that you'd be willing to do to create your quote-unquote utopian society that you desire? Wow, you're a pretty terrible person, but okay. I'll show you how to do this. It's clearly ethically wrong, but this is what I call fractionicide, where we're just going to kill all the fractions. And we'll give you your utopian society. Won't that be wonderful? Now, it's actually related to the LCD. The LCD is the weakness of the fraction, so we're going to create some sort of like genetic warfare bomb that's going to target and break down all fractions at their genetic level and destroy them. And it'll be great, according to some of us. So what is the LCD between 16, 4, and 8? What do all of those go into? 4 goes into all of them. 2 goes into all of them, but what do all of those divide into? So 16, right? Okay, so 16 is my LCD. And now what I'm going to do with the 16, I'm actually going to write this out a little bit larger. So I have 1/8 minus 3/4 x equals 1/16. And what I'm going to do is, watch this, I'm going to multiply both sides by just the LCD. 16 and 16 here. Watch how sweet this is going to be. This is going to kill all of the fractions. So the first thing we'll have to be careful of is distributive property applying here. A little bit, right? So let's see. To do 16 times 1/8. What is 16 divided by 8? 2. And then let's take that 2 and multiply by the 1, and that is 2. Okay. Oh, loop-de-2. There it is, Waldo. Wow. There we go. 16 divided by 4 is 4 multiplied by -3. 4 times -3. -12x with that x in there. And 16 divided by 16. 1, and 1 times 1 is 1. And behold, I present to you a world without fractions. You just had to get your hands dirty by committing fractionicide and killing all of them. Wow, what do you know? So let's solve this normal. How would you solve this? What do you do first?
Get rid of the 2.
Okay, just how? The same way you killed fractions? You just want to kill everything now? Is that what the problem is, Jacob?
I'm going to make it get married to -2. And then you're just going to leave. We're going to clean it.
Oh, wow, that's nice. So let's see, I'll move this 2. The 2 was positive, so to move it I have to subtract it. Once again, this minus sign does not apply to this 2. Okay? So equals, and let's see, what do I get? 1 minus 2 is? -1, yeah, 100% on that, I like it. And how do I get rid of this -12? Do I add 12 to both sides? No. Well, I was agreeing with you, I was disagreeing with myself. I apologize for the confusion. -12 is being multiplied by x, so we're going to divide both sides by -12. And behold, x equals, let's see, those minus signs, what goes on there? Yeah, Fruit Ninja. Whooshing, whooshing, right, those cancel out. And I get x equals 1/12, the same answer that I got the other way. But I didn't have to deal with fractions. But, oh, wait a minute. Guys, we killed the fractions, but they came back. It's back. Life had found a way, like some sort of like radioactive fraction zombie. It's returned and is ruining our utopian society. But we did have a pretty good run, didn't we? I mean, we had 2 whole steps where we didn't have to worry about fractions and stuff, so it was worth it. It was worth it. But I hope you feel good about yourselves. Let's see. Maybe one more question. How are we doing? Oh, we're doing pretty good.
37.
36. I'm not even going to copy in the answer there. Yeah, wait, 30 y siete.
Yeah.
I got you. Yep. Okay. Hey, I'm a math teacher. There you go. So let's see. So for this problem, this one is quite interesting. Could you describe to me what's happening with y here? What operations are occurring to it, and in what order? Just describe y's day to me. Like, what happened? So y showed up to work. What was the first thing y did?
He went inside of his cubicle.
Yeah, and what happened in the cubicle?
He was hanging with his friend.
It got added to 3, right? So y's talking to 3 and like, blah, 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 blah. This is great. Oh, how was your weekend? Oh, you watched the StarCraft 2 match too? Oh, so did I. Wasn't it crazy? Wow. Did you see Naniwa? Yeah, he used some crazy Phoenix play. Blah, blah, blah. Right? And they're talking. And then what happens to y? And then it's multiplied by -5. So notice the order that occurred in is not the one that we're typically used to. All right. So if I'm going to undo what happened to y, I have to undo it in reverse order. So it's multiplied by -5 last. So how could I get rid of that multiply by -5? You could, right? We could actually start by dividing both sides by -5. This isn't actually the way I would do this problem, but I'm going to show you this method first, and that's fine. -1 equals, and what would be left over here? The negatives cancel out, the 5s cancel out. Y plus 3. And then how would I solve for that? Perfect. Subtract 3. And I have, what's this equal to? -4. Okay, I'm getting consensus. And one of the things I want to point out is that it's kind of Englishly backwards to say -4 equals y. It's kind of cooler to say y equals -4. So, you know. So that's kind of a cooler way to do it. One of the things we're going to do today is talking about solving a little bit more complicated problems that if you simplify both sides first, that can sometimes be better. So I'm going to use the distributive property. I believe our friend Hank mentioned it yesterday. Watch what happens when I distribute first. So I'm going to multiply everyone in the parentheses by -5. And I would have -5y. And what's -5 times 3?
15.
Yeah, -15. And now to get this y by itself, what would I move first? Yep, I like it. And 20 equals -5y. And then divide by -5, right? And this is just a thing of beauty, isn't it? And I'm going to watch this. Oh, watch careful. I flipped it super quick. You didn't even see me flip it. Right? Why write that extra step if I just know I want to do the old switcheroo in the end there? That's called the reflexive property of equality, by the way. If A equals B, then B equals A. Seems to make sense. I think you would agree. So I think we're good at that for now. Yeah, I'm going to end this little homework video for now. Thanks for watching, everybody, internet buddies. Yep, bye-bye. Like my video.